In this video, Dr. Francis uses the African maize disease experiment, which was described in the previous video or video part 2, as an example to demonstrate steps in designing an ANOVA lattice plot layout using Agricola package. The analysis including variance partitioning, ANOVA, mean adjustments, data visualization, and pairwise mean comparisons.
She's going to create an alpha lattice design. She's got 42 genetic treatments, and she's going to set her block size to 6. So the blocks have to be set to this size, so that's determined by the alpha lattice, so T is divided by K. And she's going to end up doing 2 replications. So she's going to do the whole thing twice, right? So this, notice we haven't read any data in. This is simply what we need to do to design the experiment. So first thing that we're doing is we're telling the program the basic design variables are, all right? And then we're going to use this design alpha function. Okay, notice there's a difference in my script. I'm using a different version of Agricola than Victoria was. And I'm pretty sure that if you run it with these in here that you're going to get an error. Specifically, this is the one that's going to cause the problem. I would leave that out. So follow the script, and I'll make a correction to that. So what we're doing is we're using R with no data to simply design the experiment. So when you run this, you end up, if you use, you've defined sketch, and if you use outDesign sketch, you're getting the layout of your experiment right here. So this is telling you what goes into block 1, 2, 3, 4, 5, and 6 in rep 1, and what goes into those blocks in rep 2. And if you were to run this again, and so you don't have to take my word for it, you can actually do it. If we come back here and we look at this, what I've just generated, and compare it to this, so 13, 7, 2, 10, look at this, well, they're not the same, right? It really is randomizing it again every time for you, right? So outDesign, this design alpha is creating an object for us that gives us the experimental design. It also gives us this efficiency factor. Because we're not using a randomized complete block design, it really isn't as powerful, right? But the point is we can do this within the resource constraints that we have. So it is telling us a little bit about the efficiency, and we can use that factor to think about, well, what happens if I do one more rep? We can try that. Let's go ahead and change that to 3. Let's run that again. Look what happened to our efficiency factor. It went up, but not that much. It went up from 77 to 82. So if you wanted to explore an experiment, right? You could be generating this efficiency factor for different treatment sizes, different block arrangements, different reps of your experiment, and graphing that out to see where you made the most gains, right? And use this as a tool to help you design a better experiment. We haven't read in any data yet. We've just used a function in the Agricola package to help us design the field layout. So I've laid this out. If this is my field, this is my block or tier, but I'm planting in this direction, right? So now let's start to think about the data. So the data are based on a severity rating. We start scoring when we see symptoms about 7 days after inoculation. We score every 4 days. We're scoring on a scale from 1 to 5, no symptoms to dead, minimum of 3 scores, and then calculate an area under the disease progression curve. We've got 2 data sets that I've given you. One has the rep, block, treatment number, and disease score. Okay. The other links that treatment number to a group, a QTL group. So we don't need this now, but we are going to need it. Go ahead and set your working directory and read in the data. You probably already have loaded Agricola. Double check the data. This is the analysis. We're using PBIB test. We've defined block, treatment number, rep from our data, and we're using AUDPC. K is equal to 6. We can adjust the alpha value. All right, so if you want a more stringent experiment, you can set alpha to 0.01, right? We're using restricted maximum likelihood to do this. We're echoing it back to the console, though this isn't really necessary. Okay, so what does it mean to echo it back to the console? When you run that line, all of the analysis shows up. We should double check that the class level information is consistent, the number of observations is consistent, and then this estimation method is consistent with what we told the computer to do, and then we actually get parameter estimates. And we also get the fit statistics. So these aren't new to you. So the fit statistics can be used to compare this model to, say, another model. The parameter estimates, why aren't we seeing treatment there? It's because treatment is considered to be a fixed effect here. So you don't get the variance component. You only get the variance components for the random effects. What's a more important source of variance? Block within rep or rep? Rep by a long shot. Okay, so I mean that tells me something, right? It tells me that my blocking isn't really the source of concern. It's that maybe I need to repeat this even another time. If I want a more powerful experiment, I'm going to increase reps. That's how we make use of this information. I want to be a better experimentalist. I don't have to worry so much about my blocks. It's my rep that I have to worry about. So I get an analysis of variance table for my fixed effects, treatment number, right? Highly significant. And again, check our parameters, right? This is in fact consistent. That's the experiment we thought we were doing. So how do I interpret this ANOVA table? What is it telling me? Okay, so genetics matters. I mean, we have both susceptible and resistant checks in there. With respect to potyvirus resistance, then we have our QTL. So I mean, if this isn't significant, we got to worry, right? If you type this command ls and then say data2, so remember data2 is the object that we defined, you're going to see all of these things. So you don't, remember I told you that we don't have to echo it back to the console, right? This ls command tells you what's been created, okay? So ANOVA gives us that ANOVA for fixed effects that we just looked at. Adjusted means here is found within this means object. A pairwise comparison is actually being conducted here. Pairwise comparisons are a little laborious when you have 42 treatments, so I'm not even going to suggest that you open that up. This is giving us the fit statistics, which were again echoed back, right? So the AIC, the BIC, the log likelihood, okay? There's a mean separation that's produced here that appears under groups. Okay, so knowing what the program creates for you is good. You should in general be in the habit, if you create an object, use ls object to see what's there. If you're applying a function to a data set, be curious and see what it's created for you and what's there. Without echoing back to the console, we can get that ANOVA table by saying data to ANOVA. So the $ is saying, this is the object to look in, give me what you've produced under ANOVA, and look what's there. The same with the data to $ F statistics. And you can try this on groups, you can try it on means, etc. Here's the means. So that's important because what's hidden in that means there is your adjusted means. So remember what we're doing with the alpha lattice design is we're adjusting the means based on the variation in the blocks. And so I have now a table where I've done that. Okay, so it's giving me the minimum, the maximum. The standard error is invariable because the adjustment is across the whole experiment. For the next step, when I want to start comparing individuals within my treatment mean, is I'm going to use the adjusted means. So I'm going to need to write that out or retrieve it some way. The groups is giving me a mean comparison. Okay, I'm not necessarily interested in that, but I do want to show you that you can use this function called bar group for data to groups. Set the y variable, the y limit here up to 100. Density is changing the shading there. Last two is changing the orientation of the labels. Okay, but I can lay out my mean comparisons in a bar graph. So I'm visualizing the data. This still doesn't really mean anything to me. Does it mean anything to you? Not yet. So we can write those out to retain a record, right? And again, you should be getting used to this command, right? And if you do this, a new file is going to occur, is going to show up in your working directory.